This video is going to take you through the algebraic solution to a rational equation so that you can see what this process looks like. And your job is to copy down the solution in formative. If you find that it's a little hard to do this much work, it's going to be then you should probably copy it down on a separate piece of paper and then upload that into formative in the workspace. Just make sure that your photograph of your work is taken in pretty decent lighting. So the equation that we are going to solve is this. We're going to solve p plus 5 over p squared plus p is equal to 1 over p squared plus p minus p minus 6 over p plus 1. Okay, so that is a lovely rational equation. We have all those polynomials. We have some denominators there. Two of them match and one of them doesn't, and that ruins everything for everybody. Okay, so the algebraic process here is going to revolve around the idea that we need to clear the fractions. So we don't want all those fractions there. If we could get rid of all the fraction-y parts, then our lives would be much easier. So the first step in this is to factor all of your denominators so that you can see what factors you have in common. And the goal of that is to make sure that you multiply by the right thing to be able to cancel out the denominators without multiplying by extra stuff. And so when you're doing the work, it is very tempting to just ignore the numerators for a little bit, and I do understand why students do that, but we want to be careful about it. So p plus 5 in the top is fine. On the denominator there, I have p squared plus p, and they have a common factor of p. So if I factor out a p, like what times what gives me p squared, p, and what times p times what gives me p, that would be 1. And the good thing about this problem here is that the second denominator will also factor the same way. And you'll notice that I do have what seems like some weird breaks there, but there is a reason for that. And then we have the p plus 1, which cannot be factored. And I'm going to go ahead and put that in parentheses. Parentheses do not do anything there. The fraction bar acts as a grouping symbol, and then the parentheses kind of overgrouping it. But sometimes the visual of seeing the p plus 1 in parentheses just helps. So now that I have all these denominators factored, if I could multiply everything by p times p plus 1, okay, so that common denominator, so what would be the common denominator right here, okay? So we could multiply everything by p times p plus 1. So if I multiplied this fraction by the denominator, what that would do is it would cancel out the denominator. Remember, the denominator is dividing. So if I'm dividing by p times p plus 1, and I don't want to, my solution would be, well, multiply by p times p plus 1. But I can't multiply the left side of my equation without multiplying the right side of the equation by the same thing. So notice the concepts here. These are the same concepts that you did like back in elementary school with other kinds of fractions, that if you want to clear the fraction, you multiply by the denominator, and whatever you do to one side of the equation, you do to the other side of the equation to keep it balanced. Same principles, just applied in a much messier situation. So I need to multiply the right side, and you need to multiply everything on the right side. You can't multiply the entire left side by something and then only multiply part of the right side. Okay, that's not going to keep them balanced. So what I am doing is I'm going to multiply this fraction here by p times p plus 1. Now, in order to keep the equation balanced, I have to multiply the other side, and I need to multiply everything on the other side. And now you know why I left those weird spaces in there. Because I knew I was going to need to write this. Now, right here is where it's going to clear up, because if I can find my mouse, there it is, dividing by p times p plus 1, and then I'm multiplying by p times p plus 1, well, division and multiplication cancel each other out. And so we have the numerator and denominator canceling out, leaving me with just the p plus 5, which is much nicer. Then we have them canceling out here. Now, this is going to get a little bit stickier on this particular problem. I can't cancel everything out, but I can cancel the p plus 1s out, and that's why it's nice to put that in parentheses. So after I go through this step, I now have p plus 5 equals 1 minus p times p minus 6. So that's where we're at. And you can see that with that one step, it does get much nicer. That one step is a bit of a doozy, though. It involves factoring all of your denominators, choosing what to multiply by, and then getting enough of a visual of the work done that you can see what you need to cancel. Now we will distribute. So remember that this is negative p that we are distributing. So negative p times p is negative p squared, and negative p times negative 6 is positive 6p. And that is a quadratic. So that was, what was that? P plus 5 equals 1 minus p squared plus 6p. Okay, so this is a quadratic. I know it is a quadratic because I have my p squared. And your strategies for solving a quadratic are typically factoring or the quadratic formula. There are some other strategies that you could use to solve it at this point, but those are our two main ones. Both of those strategies do require that you set it equal to 0. I also really don't want to deal with a negative leading coefficient. So when we have the option to tinker with the problem and mess with it so that we don't have the negative there, that is exactly what we're going to do. So I am going to try to get a 0 on this side of the equation here. I am going to do that by adding p squared to both sides. So that's going to give me p squared plus p plus 5 is equal to 1 plus 6p. And I am going to subtract 6p from both sides. So that's going to give me p squared minus 5p. And then we're going to subtract 1. I guess I didn't write like the plus p squared. I didn't really have a spot to write it over here. Plus p squared. Sorry about that. So I now have p squared minus 5p plus 4 is equal to 0. And at this point, now you might be wondering, could I do that all in one step and just move? Yes. Like in my work that I did, not that you guys really care, but I did work this problem out before I decided, well, you know, it doesn't matter. But yeah, I did it all at one step, just moved everything over. So now you can decide, do I want to factor this or do I want to use the quadratic formula? I personally don't like the quadratic formula at all. And so I'm going to try to avoid that every chance I get. So you can go straight to the factoring. If you want to do your area model, you can. I need 2 factors of 4 that add up to negative 5. And so when I look at 4, I got 1 times 4 and 2 times 2. But if they need to add up to negative 5, the way I'll get that is with the negative 4 and the negative 1. And so that gives me p times p. And that'll be negative 4, and that's a negative 1. So yeah, p minus 4 and p minus 1. And now we engage the 0 product property, which says if you have 2 things and those 2 things are multiplied together and they give you a 0, then one of those 2 things had to be equal to 0. I meant to change my color back. Okay, and then you add 4. So you don't have to write the plus 4. That's fine. So p could be equal to 4, or p could be equal to 1. Ta-da! Now, probably a safe thing to do at this point is to go and check those answers, because whenever you have the quadratics and stuff, now we weren't doing any squaring in here, so we didn't do any actual like squaring of like both sides or anything, but you might want to plug them back in and check, make sure they work. But that is the algebraic work for solving a rational equation. It does not involve any concepts that you don't already know, but it is genuinely a very long process with lots and lots of places to make mistakes, even for somebody that knows how to do them. But your job for this problem was just to follow along and copy down the solution.